Good morning, everyone. I hope I'm audible and loud and clear. So let's begin our session. Yes. Last session, what we did, we have seen Hive HBase as well as we have done Hive user-defined function. Very very important. Now, in this second mid semester, will keep two chapters only. Uh, that is this Apache Hive, Pig, HBase, and Spark. Okay. So there are a lot of things. Only one chapter is still left that will not learn. That is streaming, Hadoop streaming chapter. Okay. It has a little bit more weight, but we'll cover at last. So again, syllabus point of view, we'll keep two chapters according to syllabus. So let me just show you. Can you see my screen? Okay. So we have studied first introduction type, only theory part. We have seen Hadoop, no SQL, only theory portion. Mining data stream is it's a very very important chapter. Lot of practicals are there with theory. Frameworks, fifth and sixth chapter, that will keep in our syllabus. Okay. Again, weightages are equal, little bit equal. So in this mid semester, we'll keep fifth and sixth chapter. We are supposed to prepare well for fifth and sixth chapter. We'll not keep chapter number four, and we'll be studying this chapter number four after completing your mid semester. Then let's see what's the time frame, how much time we get. Okay, fine. So let's begin with whatever we have left last time. Fine. Any doubt, anything from your side, anything regarding mid semester, anything regarding mid semester paper, mid one, anything from your side? Let me know. Write down chat box. Okay. So for left file today, not today, but tomorrow or day after tomorrow, I will be sharing one Google link, Google Drive link, Google Classroom link, where you are supposed to upload your file till eight practicals. But with this week, I'm expecting till 10th practical. Till 10th practical, you are supposed to upload your file, okay, in Google Classroom. So, practical point of view, there are some practicals which we may not be able to cover. We'll see those practicals and we'll remove those practicals. Okay, but I think I will targeting minimum 15 to 14 practicals. Okay, minimum 14 to 15 practicals we are targeting, right? Okay, fine. Am I audible properly? Just say yes or no. Are you getting fine? Okay. So there are some fan noise I am getting from my laptop. So that is why I ask you. Fine. Okay. So today I'll be showing you the peak as well as a big presentation. So we have seen all these things, how to detail regarding HDFS and MapReduce, partitioner, combiner, some questions, Hive, Hive UDF, HBase. Fine. So yeah, we have seen peak. What is peak actually? I hope can you see? Yes. Let me know meanwhile if you want. So peak is what? Its own language, peak Latin scripting. So peak is scripting language. It is a data flow language Yahoo has introduced. Yahoo has introduced Pig. Okay. So we have studied Hive. Hive is for what? It's like SQL's type of language where we write down our queries. I mean data analysis queries, and we are getting output. What do you see next? HBase. HBase is for what? The database, column oriented database. Now, here is a pig. It's a scripting language. We write script. Okay. So before that, let me stop sharing and let me share entire screen. Fine. So let me launch terminal. First, let me start pig. Very easy. Pig is very easy. If you have configured Hadoop, there are only two steps that you must do. Then pig starts automatically. Okay. So let me start pig only. Write on pig what says. Okay, we'll wait little bit because it takes time to start peak. Now there are two modes we can start peak. One is a local mode, second is a cluster mode. Cluster mode means it requires Hadoop. So right now I have started with peak with cluster mode where it will do some analysis. It will use MapReduce. Okay, so we'll wait little bit to start peak. Let's see if any error comes. I think it's taking time. Okay, you see. Now you see it pick MapReduce. It doesn't pick local. Didn't pick local. Now pig has been started connecting Hadoop file system at SDFS localhost 54310. It is connected with SDFS. Now you see the grunt shell. The grunt shell. This is the shell we are writing some pig queries. Here we'll be writing our pig queries. Okay. Queries in the sense script. We will say script for pig. Okay. Now let's see little bit move further. So client machine will run pig here. Client machine only will run pig. So pig is here. It will run MapReduce. So in pig, we have data like this, where this is known as a row. These are the table or attributes. So with pig, it will be like this. In the pig, the data is like this: 102. These are the atoms. These are the bag or relations. So there are two ways we can run: pig -x local, pig -x MapReduce, or only pig. So I just written the peak. That means it's in HDFS mode. The peak is running in cluster mode. It will use HDFS. Peak hyphen X local means what it will use our local file system. Okay. And there are some data types of peak: integer, float, long, double, byte array by default. Anyway, character array, bag, tuple, atom. So peak works with commands only. Peak works with commands only. Now, so there are some problems with peak. Peak, I mean, no problems, but thing is, will not consider on peak much more compared to other component like Hive, HBase. We will not see much more about peak. Okay, we'll see basics things about peak only. So you are just supposed to configure peak and just run some basic commands. Okay, and if you are really interested, you can do by yourself. Very easy to do. Fine, fine. So let's see whether this command is available. I mean, this file is available. Cat. Now here I'm going to launch a new terminal. Cat climate or CLIMATE. No, there is no such file. But let me make one file and let me copy paste this thing. So these are the temperature file. Let me check. I just written some data in climate file. Okay. Now we have to load this data. So what is this? This is the year. This is temperature. This is city name. So we have to tell peak which data belongs to which column. So here env load. Where is my data here? As this. Okay. So let me write down here. In my grunt shell, where is my grunt shell? env is equal to load. And where is my file path? So it's in home or climate. Okay, let me again check where is my file actually. It's taking too much time because there are so many files. Where is this? PWD. Home Hirsch, yeah. This is in this directory. Let me stop searching. Load home Hirsch climate. This is my file. Okay. As your now here you see your first one is your only integers are there. Temperature again it's a data type is integer. Now CT is character error. Now for CT we have to work with character error. Okay. So character error for what string we can say. So let me write down in bracket integer then temp temp integer, then what are the next data are there? CT. For that character error. Let's see whether this works or not. Error unable to check name. User Hirsch detail log file. Okay, let's check log file. Why this kind of error is coming here? First of all, home Hirsch peak. Let me check the log file. Yes, here is the log file. Peak script failed to parse. Data storage exception unable to check name. Data storage exception caused by unable to check name. Now, can anyone tell me what's the problem here? Yes, from your side, anyone? Let me share this again, only share this log file. I need answer from your side. What's the problem here? What we have done and what was the problem? Can anyone just tell me? Yes, here. These are the exceptions. Zoom in and just tell me. Why we are getting this exception? Any guess? Any good guess that would be welcome? Yes, Nidhi, Miloni, Harshil Kumar, anyone? What's the problem here? Based on this exception, what you can figure it out? Yes, anyone? No one? No one has a good guess? Anyone? Fine. So let me tell you what's the problem. What we have done, we have started pig in a cluster mode. They started pig in a cluster mode. So cluster, I mean pig is based on what? It requires in cluster mode it requires SDFS file system, simple one. It requires SDFS file system, but here we have not started Hadoop, which has SDFS. We have not started Hadoop, which is a SDFS, so it doesn't get the Hadoop. That is why some errors are there. So what we are supposed to do, we must start first Hadoop and then execute peak query and all this thing, right? Okay. So from another one more terminal, let me launch. Okay, let me share my entire screen again. From the another terminal, start all.sh, password. Yes, what is peak? Why it's used? We all will see. Just we'll do some commands, and I will tell you what is peak, why it's used, and some of the use cases. JPS. Okay, name node is there, data node is there. Okay, fine. So now I will again run a command of peak. Let's see, this time there should not be any error. Okay, I think the job is done. No error. This is just info. You see, this is just info. Now we have just uploaded this climate to this year temp. Now let's check it out. Whether where it stored this pig file. User. This is my pig file first of all. User. There is I don't see big file here. Anyway, let's see another command. What is that? How do I see? env is what? Okay, let me describe this env here. The pig here. describe env. You see, env is a one sort of table or sheet, we can say. Okay, where this is described. Here is what integer, temperature is integer, city is character, error. Okay, env is one sort of table that we describe. So which script we have written? env is equal to, in this env table we have loaded our data as this uh, schema. Okay, fine. Okay, now if we just dump env, if we write down dump env. Okay, some exceptions are there. uh, Fail to produce result. It is not fail to read data from home, harsh, climate. Fail to read data. Okay. I think I should give climate is what I have given a text file or what. Let me check once again. Okay, climate is what, it's not a text file. So rename climate to climate.txt. Okay, rename is not there. Let me just go to this climate.txt only, but anyway. Fine, now let's try again. Now we are loading climate.txt. We are loaded. Now the dump. Okay, again exception. It is not able to find. It's trying to search in this. Okay, fine. Let me put that file in a SDFS. Load in SDFS root climate.txt. Okay. Now we have loaded this location, and now let me put that file here in Hadoop. So how do I put file in Hadoop? What was the command? Hadoop put. What was the command to put file in Hadoop? Let me just search. Put command. Hope I'm looking for entire syntax. So we don't just waste time. Hmm. Yes. Hadoop fs hyphen put. Yeah. Where is that file? It's in home or climate.txt. Where root. Okay, let's check whether the file is available or not. Yammer.txt is here. Now let's again work on this grunt shell. We want to see. um, Now it's executing. 50% completed. Now you see dump. You see a lot of process they have done. Now it's getting. What was our thing? It was not getting file. So successfully input 8 records, successfully stored 8 records in this file temp. Okay. So it has returned that thing in this here. I'll tell you what are these dump and all this is. Just hold on. Temp. No, actually I'm not able to execute temp here. But anyway, so it has put in a well, we can say memory. Dump means memory. Okay. So we can do some calculation on that data. Once we load the data, we can do some calculation. Okay. Now let's see more commands on pig. Okay. Now we can apply filter env. One more table kind of thing. So what happens? You see with this script, what happens? Filter env is another one sort of table. Filter, we apply filter command on env by temp greater than 30. Now whatever we have given the schema, we have given schema as a temp. Where temperature is greater than 30, we want all those data on it. Okay, so here you see the schema we have given here. Oh, there are no errors. Schema. Okay, gone. Anyway, so let me just enter. Okay, exception. Passing path filter env filter env by temperature greater than 30. Was expecting one of these. Okay, some fill. Okay, file fill env. Now it's done. Now if we write down dump fill env, now Indian data will be written here. Now let me check again here. I can show you all this data whatever done. You will not see here. Anyway, I think I'm not able to see the output. Let me take you this command. Because query is executing, but I don't see the output here. So in background, it's invoking map reduce, and yeah, I think data is in different format. You see here, you see some problem we have encountered anyway. But the climate.txt, everything is fine. Let me check again climate.txt. Everything is written in a fine manner. Let me remove this also. Fine, anyway, we have launched Peak, we are writing scripts and some problem with the data. Anyway, so what we'll do? First, let's see the presentation, then we'll come back to this. What is Peak actually? Big data processor. What is Peak? Apache Peak is an abstraction over MapReduce. It is a tool platform which is used to analyze larger sets of data, representing them as a data flows. So Peak is generally used with Hadoop. We can perform all the data manipulation operation in Hadoop using Apache Peak. So write a data analysis program. Peak provides a high-level language known as a Peak Latin. Using Peak Latin, you are supposed to write a code. Okay. This language provides various operations using which programmers can develop their own function for reading, writing, processing data. Now, why Hive, why Peak are there? Because it's not convenient to write Java program for a very small function. Let's say we want to develop very small function. Every time we have to write Java program for Hadoop, right? We have to compile it to jar file and then run the jar file. If any problem comes, then it will be like a problem. Like every time we have to change in Java code, right? It's a headache. It's a problem. So instead of that, we have Hive, where we just write down the queries. We put data in some table format and then we write queries. Another component is Peak. Okay, where what we do here in Peak, we write some script with small scripts. Okay, using that we can run our data. Okay, so using Apache Pig, we have to write our code. We have to write our data. Okay. So all these scripts, so uh, all these scripts are internally converted to map and reduce tasks. Now this one is second line is very important. All these scripts are internally converted to map and reduce tasks. Apache Peak is a component known as a Peak engine that accepts the Peak Latin script as input and converts those scripts into map reduce job. So what Apache Peak is, it is a Peak Latin scripts. Okay. So remember this one. Peak Latin engine that will take input and convert into map reduce job. So I hope I'm clear. Everyone is getting. We have started with Peak. We started with some basic commands and we are seeing the presentation. Everyone is getting? Okay. So why do we need Apache Pig? So there are a lot of descriptions out there, but let's see one by one. Using Pig Latin, programmers can perform map reduce tasks easily without having to type complex code in Java. That's what I say. It uses multi-query approach, thereby reducing the length of code. For example, operation that would require to type 200 lines of code in Java can be resolved by typing less than just 10 line of code, 10 line of an Apache Pig. So Apache Pig, what it does ultimately reducing the development time. Okay, same as Hive. Pig Latin is SQL-like language and it's easy to learn. Apache Pig when you are familiar with SQL. So you see, like the Hive, it is also SQL type of language. So Apache Pig provides many built-in operations to support data operation like joins, filter, ordering, etc. In addition, it also provides nested data like tuple, bags, maps that are missing from MapReduce. So rich set of operators are there. It provides many operators to perform operation like join, sort, filter, etc. It's easy of programming. Pig is very easy of programming. So it's a similar to SQL and easy to write a Pig script if you are good at SQL. So optimization opportunity. The task in Apache Pig optimize their execution automatically. So the programmer need to focus only on semantics of the language. Now these are the features. Extensibility. Using the existing operator, user can develop their own functions to read, process, and write data. Pig provides the facility to create user-defined functions in other programming languages such as Java and invoke or embed them in Pig script. And it handles all kind of data. Okay, some comparison is given. Let me tell you, Pig engine is converting the scripts into MapReduce tasks. Okay, so Apache Pig is a data flow language, and MapReduce is a data processing paradigm. High level language, MapReduce is a low level and rigid. Performing a join operation in Apache Pig is pretty simple. In MapReduce, it is quite difficult to perform a join operation between data set. So this one is advantage. And in-voice program with basic knowledge of SQL can work conveniently with Apache Pig. Exposure to Java is must to work with MapReduce. So in order to write MapReduce program, we must learn Java. Apache Pig uses multi-query approach, thereby reducing the length of the codes to great extent. So MapReduce will require almost 20 times more the number of lines to perform the same task. There is no need for compilation on the execution. Every Apache Pig operator is converted internally to MapReduce job. Whatever we write query, it internally converts to MapReduce job. Okay, and whereas MapReduce job has a long compilation process. Fine. So what is Pig versus SQL? So Piglet is a procedural language. SQL is a declarative language. Apache Pig schema is optional. Whatever schema we give is optional. You can store data without designing a schema. The values are stored as a $01, $02. We'll see this again next time. Schema is a mandatory in SQL. The data model is Apache Pig is a nested relational. The data model used in SQL is a flat relational. Apache Pig provides limited opportunity for query optimization. There is a more opportunity for query optimization in SQL. Okay, these are the difference. Now, what is the difference between Pig and Hive? So Apache Pig is using what is called Pigletin, created by Yahoo. Hive is using what HiveQL, created by Facebook. Pigletin is a data flow. HiveQL is a query processing language. Pigletin is a procedural language and fits in a pipeline paradigm. HiveQL is a declarative language. Apache Pig can handle structured, unstructured, and semi-structured data. Hive is mostly for structured data. Now here's the difference between Pig and Hive. Okay. What is the application to process huge data sources such as web, blogs, to perform data processing for search platform to process time-sensitive data loads? So, what is the history? In 2006, it was developed as a research project in Yahoo, especially to create and execute MapReduce job on every data set. In 2007, Apache Pig was open source via Apache Incubator. In 2008, the first release of Apache Pig came out. In 2010, Apache Pig graduated as an Apache top level project. So this is Pig architecture. Now, not that much important. Pig is not been asked in GTU yet, but still, if you know, that is very good. So Pig Latin scripts, it goes to this grunt shell, the way we are writing, and parser, optimizer, compiler, execution engine. I think these steps you are studying in compiler design, and then it goes to the MapReduce, and then we have GC SDFS. These are the top of SDFS. Okay, this is the architecture. Very simple. So what are the internal components are there? The parser is what initially the Pig scripts are handled by the parser, checks the syntax of the script, does type checking and other miscellaneous checks. The output of the parser will be DH, directed acyclic graph. Okay. So it creates the internally creates a graph which is acyclic, which is not repeating. There are no cycles. Okay, that means tree. You see, in data structure, tree has no cycle. That is why it's called as a tree. So it makes a directed acyclic graph. There is a direction from one point to another. There is a direction. Okay. So they which represents peak latent statements and logical operators. What is optimizer? This DH is passed to logical optimizer, which carries out the logical optimization such as projection and push down. Then we have compiler. Compiler compiles optimized logical plan into a series of MapReduce jobs, and then the execution engine which submits to MapReduce. This statement submits to MapReduce job. Okay. Okay. What is the data table? I think we have seen this data table, right? Okay, fine. So today is a engineers day. Fine. So we don't have session between 10:40 to 11:40. You are supposed to join one link which is been shared by your CC. You might have you received any mail regarding some Cisco link where our faculty will take one data scientist session. You are supposed to join the session. Have you got any link regarding that? Yes or no? Fine, fine. So we'll keep up to here. Tomorrow we'll see more about peak. We'll complete the peak and we'll start Apache Spark. Yes, in Telegram. We are supposed to join after 10:40, right? Everyone? Fine. So everyone write down number in chat box. We'll end our session here now. The timing is between 11 to 12. I hope everyone has written their number. Let me stop sharing. Let me stop recording also. Okay. Thank you everyone. We'll meet tomorrow.